Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to set up and use a Cadence Fidelity feature in just a few minutes. Today, we are going to show you how to set up porous media properties for a domain in the Fidelity PBS simulation workflow. Fidelity PBS is the solver of choice for internal flow and thermal analysis. For the pressure-based solver, the Darcy-Forchheimer model has been implemented for modeling the porous media. Let us see with a simple channel flow problem how this is implemented. In this, you can see a rectangular channel with a cylindrical porous media separated by an annulus wall and open via the inlet and outlet. Using the Fidelity Hexpress measure, we create a multi-domain mesh with automatic conformal connections. While setting up the simulation setup, make sure you select both the channel domain and the porous media domain. Now, to set up the porous media in the simulation setup. In Fidelity PBS, the porous media model is available as an optional model in a specified fluid domain or zone and needs to be checked on to open up the porous media dialog box. The Darcy-Forchheimer formulation can be set up both as a homogeneous formulation or a non-homogeneous directional formulation. The coefficients of the parameters in each methods are shown. In the non-homogeneous formulation, you can also specify the flow and the normal axis. You can also check the output porous force option to record the net force and select whether the flow inside will be within a laminar regime or not. All of these parameters can also be manually entered in the .inp file in the porous region segment template by specifying the porous zone name. After the simulation is run, flow phenomenon can be analyzed within the Fidelity environment or in Metapost processor when using the PBS standalone solver version. If you like this video, be sure to click the thumbs up button or subscribe to our channel for more videos like this. If you have any questions, comments or suggestions, drop us a line below or connect with us via LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.